Okay, so in the previous one, we have studied about the super elevation, derivation of the super elevation. Now, the derivation of the super elevation, we have used only the derivation of the super elevation is based on the velocity or speed of the vehicle. So, therefore, we got that equation E plus F equal to V square by GR. Now, basically, that condition is true for a single type of vehicle or singular type of speed. Now, in Indian condition, what happens? There are different type of vehicles which have different speed parameters. Some of the vehicles are moving at 80 kilometer per hour speed. Similarly, some of the vehicles are moving at 20 kilometer per hour speed. So basically, there are large variations of the speed of, of vehicles in the Indian condition. So basically, Indian condition is not like as the foreign condition where each and every vehicle maintain a uniform speed. In Indian condition, there would be different types of speed, and the vehicles of different speeds are generally moving in a particular road section. So in such cases, if you design with the design speed that is V, then for the fast moving vehicles, it could be better if you provide the super elevation, but for the same super elevation could not be comfortable for the slow moving vehicles. So for this reason, for the mixed traffic condition, we have to think of some other things. Okay. So there are some other things which also uh, impacted that super elevation. So in such cases, there are separate provision for the mixed traffic condition, separate condition for the mixed traffic conditions. So for the mixed traffic condition, there are different steps which you have to follow while designing the super elevation. Okay, so what are the design steps? So there are different design steps, but basically the main formula for that super elevation would be same. So what was our main formula for the super elevation? So our main formula was E plus F equal to V square divided by GR. That is true when V is in meter per second, and or otherwise E plus F equal to V square divided by 127 R when V is in kilometer per hour. So for our super elevation design for the mixed traffic condition, our first step is wait a minute. So in such cases, what you have to do, you have to find out the value of the super elevation, neglecting the friction value. So your friction value would be 0, neglecting the friction value and considering 75% of the design speed. So here instead of V, you will consider 0.75 V or 0.75 of V, 75% of the design speed. So if you consider the 75% of the design speed, your equation would be E equal to 0.75 V whole square divided by GR, that is 75% of the design speed, where V is in meter per second. Or if you want to calculate directly through kilometer per hour, in that case directly you can get V square divided by 225 R. Okay, so in this way, first you have to calculate what is the value of the super elevation or what is the value of E. Now you know the maximum allowable limit of the super elevation is 0.07. Now in this way, if you find that your value of the super elevation is more than 0.07, then you have to follow step number 3 and step number 4. That is the other steps you have to follow. So first you have to check whether your calculated super elevation value is within the limit, that is within the 0.07 range. If it is less than 0.07 or equal to 0.07, in that case it is okay, you can adopt that value. Now if it is more than 0.07, in that case you have to adopt the value of the maximum super elevation, that is 0.07, and you have to find out what is the coefficient of the friction value. Now how to find out that coefficient of friction value? In that case, coefficient of friction value could be estimated using E value as 0.07, and here you will consider full design speed. So in that equation, E plus F equal to V square by GR, you put the value of E as 0.07 and the value of F have to be calculated. So you will find that F equal to V square by GR minus 0.07. Or if you do it in kilometer per hour, in that case it would be V square divided by 127 R minus 0.07. Okay, now this is your third step. Now by this step, if you again find that your value of coefficient of friction exceeds 0.15, then you have to follow the fourth step. So if it is not exceeding 0.15, in that case you can say that if you provide the maximum super elevation of 0.07, in that case it would be safe in terms of the coefficient of friction value, because if you provide maximum super elevation, in that case also your coefficient of the friction value is remain within the limit. Okay, now if it is more than 0.15, then you have to go for the step number 4. So in that step number 4, you will put the value of E as 0.07 and value of F as 0.15, and you have to find out what is the speed value. Okay, so speed value E plus F equal to V square by GR. So you put the value of E as 0.07 and F as 0.15, and you have to find out what is the value of V. Now, if the calculated value of V is lesser than design speed, in that case you can provide the maximum super elevation and maximum coefficient of lateral friction. Now, if that calculated speed is more than the less than the design speed, in that case you have to restrict the speed over that area. That means that the design speed cannot be provided over there, and you have to restrict the speed to maintain the safe passing through that horizontal curve. Otherwise there may be chances of some accident over that place. So let me summarize the steps. What are the steps? First step is you have to find out the coefficient super elevation value, neglecting the friction, that is your F value would be 0, and considering 75% of the design speed. That is your first step. Your next step is you have to find out the coefficient of the friction value providing full super elevation. Okay, that is your second or third step. And next, if you find out that your F value is more than that 0.15, in that case you have to put the maximum super elevation value as 0.07, and you have to put the maximum coefficient of friction value as 0.15, and you have to find out what is the speed value. So these are the steps to calculate the super elevation in the mixed traffic condition. Okay, after that we'll solve one problem. So let us first discuss this thing. Now, attainment of the super elevation. Now, attainment of the super elevation means how in the field you will attain the super elevation in the horizontal curve. Okay, so there are basically different methods to attain the super elevation or to implement the super elevation. So one such methods is elimination of the crown of the cambered section. Elimination of the crown means if that is a road, basically that is your camber, and the topmost portion of the camber is basically called crown. So elimination of the crown means you are removing that crown, or you are shifting that crown in that particular other direction. Okay, that is elimination of the crown. So by that elimination of the crown, you can increase the height of the pavement in the outward edge. And another one is rotation of the pavement to attain the full super elevation. Rotation of the pavement means, suppose one pavement section is there, so one particular axis is there, you just rotate that pavement either in this direction through the central line, or either from the with respect to the inner edge, you can rotate that pavement section until you get the full super elevation. These are the two methods of attaining the super elevation. So first one is elimination of crown of the cambered section. So here first method is outer edge is rotated above the crown. So basically if that is the outer edge, in that case you have to just raise the level of the outward edge so that it will match the designated super elevation over that area, and here one uniform line would be formed. Okay, so that is the your rotation of the outward edge so that you can match with the super elevation. Okay, so that is your first method. Now the advantage of that method, disadvantage of the method is small length of the road. Here whatever road is there, you can only provide that portion in a small length of the road, and cross slope less than the camber. So here after that, whatever cross slope you will be getting, that cross slope would be lesser than the camber, so it will create some problem in the drainage consideration. Okay, so for that reason only you will find that drainage related problem. Next method is crown shifted outwards. Crown shifted outwards means, so initially it was the crown, now you are gradually shifting the crown outwards. Okay, gradually shifting the crown outwards. So that is your crown shifting outwards. So the disadvantage of this, large negative super elevation on the outer half. So in this portion, if any vehicles are coming from the opposite direction, in that case, large negative super elevation may be there. Drivers have the tendency to run the vehicle along the shifted ground. So all the drivers have a tendency to move their vehicle along this portion. So all the portions of that vehicle of that road may be empty, and because of the excessive wear and tire in that portion, therefore this portion chances of the damage of that portion is higher than the other section. Then our next method is rotation of pavement to attain full super elevation. So in such cases, you have to rotate the pavement. So first method is rotation above the center line. So if you rotate above the center line, in that case, your outer edge would be raised above and your inner edge would be down for the same amount. Okay, and you have to provide the super elevation of e by 2 e by 2. Suppose your total super elevation is 7 mm. In that case, you have to provide, you have to lift outer edge of 3.5 mm and down that inner edge of 3.5 mm. So ultimately your total super elevation would be 7 mm. So in that case it will be get halved. Okay, now this type of thing have one problem is there may be accumulation of the water in the inner east portion, because that is basically below than the side level, and therefore this portion may get damaged easily. Now the advantage of this method is the central line of the road remains same. There is no elevation difference of the central line in the horizontal curve than the other portion. And another advantage is there, that is the total earthwork is balanced. Total earthwork means you are excavating this portion to make it at that level, and you are uplifting that portion. So whatever artwork you have done over there or you have removed from this place, you can directly use this over there to lift that portion. So therefore in that case your artwork, okay, is balanced. So this is one situation. So in maximum cases this method is followed. And another method is rotation about the inner edge. So here rotation about the inner edge. So in such cases, one disadvantage is the central line of the road is get changed. Okay, so the central line of the road would be changed from the initial portion. So that is one disadvantage for this case. Here no drainage problem would be there, or water accumulation problem would be there, but the artwork provided here is not balanced. You have uh, to carry the soil particles from other portions or other sides to accumulate it for that elevation up of this outer each portion. Now this is the numerical. You have to solve this. The design speed of a highway is 80 km per hour. There is a horizontal curve of radius 200 meter on a certain locality. Calculate the super elevation needed to maintain the speed. Okay, that is for your mixed traffic condition. Calculate this portion. So first I am telling you the steps to calculate this. So first step would be E equal to, if you directly want to use that kilometer per hour, v square by 225 r. So from here you have to find out what is the value of E. Okay, this is your step one. I'm writing this question in the chat. And opening that initial portion so that you can directly have a look about different formulas. So that is your first step, equal to p square by 225 r. Using this you have to find out what is the value of E. So speed is 80 km per hour and radius of the curve is 200 meter. Okay, so you are getting the E value as 0.142. So basically, whatever value you are getting, that value is more than 0.07. So you have to go for the next step. So in the next step, what you have to do, that is your consider that your E value as 0.07, and using that equation, you have to find out what is the value of F. Okay, so your value of F would be V square divided by 127R minus 0.07. So using this, find out what is the value of F. So it would be 80 square divided by 127R minus 0.07. F equal to 0.181. So whatever value you are getting, that value is more than your 0.15. That value is more than 0.15. So in such cases, what you have to do, you have to go for the next step. So in the next step, you have to put the E value as 0.07 and F value as 0.15, and you have to find out what is the speed value. So your 0.15 plus 0.17, that is your 0.22. So your E plus F, that is 0.22, equal to V square, that is the allowable speed, divided by 127R. Or you can directly use that formula to find out what is the speed value. Va equal to root over 27.94 R kilometer per hour. Using that formula, you can directly find out what is the speed value. So find out the speed value. Yes, that is your equation. If you want to directly use that kilometer in per hour, that is your equation. So the value would be 27.94 into 200, root over 27.94. Yes, that is a value that is 74.75 kilometer per hour. Now the thing is, your design speed was 80 kilometer per hour, but here you are getting your allowable speed is 74.75. So for this reason, you have to restrict the speed over there. So from this speed, what you are getting, that the maximum allowable speed for that section of the road is 74.75. The vehicle cannot exceed that speed. If they exceed that speed, in that case it will causes either transverse skidding or overturning of that vehicle. Therefore you have to install some signpost over there, warning sign over there, and you have to put that your maximum uh, allowable speed over there is 74.75 kilometer. You cannot go more than this. So here in this question you have to restrict the speed in this way. I think all of you got this. So let me take the attendance. Okay, you can leave.